Hello everyone, welcome to the live class. So guys, today we are going to have another very important session in which we will be discussing some more important questions, concepts and very important points in this session today. So I hope that the discussion which we will be doing today in the session will be getting clear to all of you. But in case if anywhere you will have any doubt, you can surely let me know about it. So before going ahead with the discussion, I'm just going to show you some slides here, which are the important slides we are going to have. So have a look at this one. This is about the Unacademy learning app. This is about the session itself. This is something about me, and this is going to be about the community feature we are having on Unacademy learning app, which will help you to get the latest updates, to know about the new courses, many important points and many new things you will get to know on the community tab in Unacademy learning app. The next thing we are going to have is this thing, which will be helping you to save more. And even if you were waiting to take the subscription or you want to start your preparation under the guidance of top educators, in that case you can take the subscription and use and apply the code that is Anjali Live as mentioned here on the screen. By using and by applying this code, you will be able to get the discount in the total subscription amount. So generally we are gonna have the 3 months, 6 months, 1 year or 24 months subscription available. But right now for your upcoming exams, we are also having the 9-month subscriptions available. Okay, so you can have a look at this, but it is just going to be the limited period offer. Okay, and if you don't want to miss it, take the subscription now, use and apply the code that's Anjali Live to grab this offer too. Also guys, if I'm going to talk about the next thing here, that is uh, like since in upcoming days even so many new courses by the top educators will be starting on Unacademy. So even if any of your friends were waiting to take the subscription and they don't want to miss it, they want to take the subscription, you can share this information with them and let them know about the latest offer too, so that they will be able to save more and they will be able to take your preparation to the next level under the guidance of top educators too. Let's go ahead. Let me just show you the another slides which will be helping you to know about this part, that what benefits you will get if you will be taking the iconic subscription. So all the details about it have been shown here on the screen. So all these benefits you will be getting. Even now the notes are available on the learning app, which will be helping you to take your preparation to a very good level. Another thing is here, that's about the plus subscription. So guys, notes are even available on the learning app. Other than that, what are the benefits you will get, all the details have been shown here. So I hope each and everything will be getting clear to every one of you. And this is about the light subscription. This is going to be the slide which is going to show you the plus, iconic and the light subscription, and the referral code has also been mentioned here. So if you will be proceeding further to take the subscription, or you are going to share this information with any of your friends, then you can share all these details with them so that they will not be missing this offer and they will be able to grab it too. So this was all about the important offers and the Unacademy subscription. Now we will be moving ahead to do the discussion about the contour integration topic. So guys, as we all know, there are great chances for us to expect the questions from the contour integration in our upcoming exam. Clear? So in that case, like, what are the things you need to know and what you need to prepare? All that I'm gonna consider in this session today. What are these things then? Let's talk about it. Step by step, I will be explaining everything to you. So if you're the one who is new to this topic, who doesn't know about it, who is having no information about this topic, don't worry, I am gonna let you know everything. Done? The first thing is, normally whenever we'll be having any question now from the integration part in our exam, so that will be our contour integration question, right? Another thing is, if that is our contour integration question, what next we need to take care of and what other things we have to consider. So basically, whenever, like as per the Cauchy's residue theorem, if we will talk about the integration over any closed contour, it's going to be 2 pi iota into sum of residue at all those poles which are lying within the contour. Okay, so this is how we will be able to consider it. So integration is equal to 2 pi iota into sum of residue, and residue at all those poles which are lying within the contour. Okay, that's what you have to consider. Now, okay, the integration we are finding here, and that's due for the closed contour. Okay, what are these closed contours? That should be clear to you. So let me just tell you, closed contour can be a circle, any particular figure given to you, which is a closed one. For example, I'm going to draw it here along with the axis, and this is going to be the closed one. Okay, so it can be in any way you can have it. Can be a kind of parabola or any other shape, or you can have it this way. Done. So any closed contour. So contour part clear, it can be in any way given to you, or whether it is just equation of the circle or any such thing. Another thing here we have to consider is that, okay, we got the contour, what about the residue now? From where we will get this residue? So before understanding the residue, you have to understand the poles, because you will see when I have explained this equation, that is I is equal to 2 pi iota into sum of residue, I said that we have to find the residue at the poles which are lying within the given contour. Okay, so within the given contour means what? Within this, if this is the contour. So if there is any point outside, do we also need to consider it? The answer is no. But only the inside points you have to include, or you have to find the residue for those inside points. Okay, I hope it's gonna get clear. Now, next thing is, okay, we got it. It should be inside, not the outside one. And when it is inside only, then we will find the residue. What next? The next thing is how to find the poles. They should be inside, we got it, but how to find the poles? So poles are basically going to be the finite values of the term, or the value of that thing for which you are finding the integration, at which the function will be infinity. For example, function of z dz. Okay, so if this integration you want to solve, so value of z at which the function will be not defined or infinity, that will be what? That will be your what? The pole of the given function. At the same time, once you get that value, you can easily check it out, is it lying within the contour or not. Okay, and accordingly you will go ahead whether you have to find the residue at that pole or not. Okay, so let's just take some examples. For example, at place of function fz, we are having 1 upon z minus 2. So what will be the pole now at that point? So pole is basically, we find it by equating the denominator with 0 most of the time. But it's not like always it's going to be the same case, but most of the times it is gonna work. Why? Everybody knows 1 upon 0 is infinity. So what we want to consider, we say like, okay, when we are equating the denominator with 0, we can easily get to know about the point at which the denominator value will be 0, and then that will be our pole, because pole is simply the finite value of z at which the function will be infinity or not defined. Okay, now next thing, once you're gonna get it, excuse me, this is the pole. Clear? So now the point is, if this is the pole, what next? The next thing is that you have to see whether it is lying within the contour or not, depending on what contour has been given to you. If it is lying within the contour, then in that case you will consider that, okay, I have to find the residue on it, and then I'll be getting the final integration answer. But next point is, okay, you understand how to find pole, and then you have to check like whether the pole is existing within the contour or not. But the next thing is how to find residue at the poles. So guys, for that I'll talk about the poles a little more. So basically, let's say fz is equal to 1 upon z minus, it's going to be 1 to the power 4, like overall power is 4, z minus 3. This is what you have. If I will say, okay, I want to find the poles from this one, even in the numerator I can have z cube or something else written. It is even all right. So poles are what? When you will equate z minus 1 with 0, you will be getting z is equal to 1. Z minus 3 with 0, you will get z is equal to 3 as the pole. Now find the order of the poles. So it is what? Order 4 you will have here. Okay, so what is the order? Basically the overall power of that term from which you are getting the pole. What is the order of this one? it's going to be order 1. Clear? That's how you will be able to get it. Order 4, order 1. Okay. If in case you will be having any doubt, you can surely let me know about that and we will be trying to consider it. Now the next thing is, depending on the order of the pole, you will be finding the residue. So how we are proceeding further? Step number 1, we will be checking out our contour. Second thing, we are finding the pole. Third thing, we are finding whether the pole is existing within the given contour or not. If yes, we'll go ahead to find the residue. And after checking the order of the pole, you will be selecting the formula to find the residue too. So let me just show it to you that how you will be able to find the residue. So as I've told you, there can be different order poles you can have. Okay. If I'm going to talk about the next thing here, that's going to be, if there is order 1 pole, or there is going to be a simple pole, then what will happen? Or if there is going to be order n pole, n means n is greater than 1 here. Okay. So then how to find the pole or residue at that pole? So basically for the first case, the common formula is limit z tends to a, z minus a, fz. Fz is the given function for which you want to find the integration. Okay, z minus a, fz. Now simply when you do or use this formula for the simple pole, which is the order 1 pole, you simplify it and you get the answer. Okay, that's quite simple and easy. But at the same time, sometimes it happens that you are using this formula. A is the pole here basically. Z is equal to A is the value of the pole. So when you are using this formula, it can be like Z is equal to 2, 1, 4, whatever you are getting. So basically when you will be using this formula, in that case, what will happen? In that case, you will have to consider that after you are using it, it should give you the simplified answer and it should not make the things complicated. By chance, if it is making the things complicated, then what you have to do? Then in that case, you will have to consider the next thing, which is the next formula to find the residue at the simple pole. So what it will be numerator. For example, your given function is in fraction form, which is numerator is there, let's say phi z, and denominator is there, which is psi z. So in that case, your residue will be, this is the functions form I have given you for which we will be finding the integration. So our residue in that case will be integration. Simply the residue will be numerator as it is, but first order derivative of the denominator we have to consider. And we have to put z is equal to a this way. This is how you are just going to get the residue at that particular pole. Okay. Numerator as it is and the first order derivative of the denominator. Also guys, one more thing. When we will be going for the second formula, because you will only go for that second formula, which is for fraction, if your first formula is not giving you the answer quickly, easily, and not making the things simple but making the things complicated, then you will not use first one, then you will go or try for the second one. Otherwise, no. So when you go for the second one, in this case, you also have to consider that the denominator's value at the pole should be 0, but the numerator's value at the pole must not be 0. Okay, this is what you have to consider. If I'm going to talk about the next thing here, which is just simply if you are having the order n pole anytime, that means order of the pole is 2, 3, 4, 5, anything like other than 1 or greater than 1. So in that case, how to find the residue at the order n pole? So it's going to be 1 upon factorial n minus 1, dn minus 1, dzn minus 1, z minus a to the power n, and fz. So firstly, you will solve this square bracket term, then you will do the differentiation, and then at the end you will apply the limit, that is z is equal to a, where a is the pole you found at which you want to find the residue. So this is how you are going to find the residue for the order n pole. Okay, so 3 formula of finding the residue we have studied till now, and as I have told you, I will be telling you everything you need to know about this topic to solve any such type of question. So that's what we are doing right now. Once you have considered this part, what next? The next thing is that we are going to have one more formula which is applicable for order 1 pole as well as order n pole, both of them. So what is that formula? It's going to be see, let z is equal to a is a pole. Okay, it can be order 1 pole or order n pole, anything, but z is equal to a is a pole, and a can have the value 1 2 3, anything like that, like whatever pole you will be getting. Then you will consider z minus a is equal to t, and then your coefficient of 1 upon t will be considered as residue. So this is how you will be finding it. One more thing, everywhere from your expression you will try to remove z, means you will be replacing z with t plus a if there is only z present somewhere in the expression. Otherwise, if you are having just z minus a present somewhere, you will have to consider it equal to what? T, and then only z wherever it will be t plus a. So basically you are trying to remove z from your complete expression in any way, how that is present. Depending on that, you will put the value and replace it. And then coefficient of 1 upon t is what? It's going to be residue. Please tell me if in case there was any doubt you will have. And if it is clear, we can go for the next one. So now the next thing is, this was the like basic to basic discussion about the contour integration as per Cauchy's residue theorem, then poles, then what poles you have to consider to find the residue further, then what is the formula for the integration, all that I have told you. So these steps you will generally have to take. Once you find the residue, you just have to put it in the integration answer, which is 2 pi iota into sum of residue. Once you will put it there, you reach to the answer. Now what next? The next is, if you will have different type of questions, then what you will do. That's what I will tell you now. Give me a second. Okay, let's go ahead. So now we are going to talk about different type of questions. The one is basic one, where you will be having just the we are having everything here. Okay, let's go ahead. So basically we are going to have, let's say, integration over c. C is a contour here, which is going to be c such that mod z minus center of the circle is equal to radius. So what will happen in this case minus z minus center, for example 2 equal to 4. So that means z is equal to 2 is the center of the circle if I will equate it with 0, and 4 is going to be the radius of the circle. Okay, so z is equal to 2 is center and 4 is radius, right? Another thing, if we will talk about that, so that is, even you can have it given to you as z plus 1 is equal to 4, but still you will equate it with 0 and you are getting z is equal to minus 1, which is the center, and 4 is the radius, right? That's how you will consider it. Now what next? So C is given to you. Generally we are going to have the circle equation given for that, so that's what I have explained you. Function of z dz, any function of z can be there, so you know different formula to find the residue. So depending on what kind of function has been given and what you have to find, you can go for that. Now next thing, what are the steps you have to take to finally get the answer or to solve this integration? Step number 1 is find the poles. Check out whether the poles lying in the contour or not. If they are lying within the contour, go for the residue in the next step only for those poles which are within the contour. Once you get the residue, you just have to use the integration, which is 2 pi iota into sum of residue. But I want to make one more thing clear here, which is regarding the direction. If the direction of the contour is clockwise, then your integration expression will be minus 2 pi iota into sum of residue. If direction of the contour will be anti-clockwise, then this formula. Okay, so I hope you are getting it. Anti-clockwise is also known as counterclockwise. Sometimes students get confused. Oh, counterclockwise. They focus on clockwise word, but they forgot about the counter. Counterclockwise, same as anti-clockwise. Just clockwise means the clockwise. Okay, let's go ahead. This was the one type of question. The another type of question is when we are having integration minus infinity to plus infinity, f, z, dz. So in that case, what will happen? In that case, again, you will find the poles is step number 1. But your step number 2 is quite different here. That is, the poles which are lying in the upper half of the complex plane, that's going to be what? That's going to be the poles you have to consider, or on the purely real axis. So you have to consider all these poles. Okay, poles which are lying in the upper half of the complex plane or on the purely real axis, you have to find the residue for those poles. So you have to find the residue, okay, for only these poles. Next is your integration, which is going to be the finally 2 pi iota into sum of residue. If your poles are going to be, or the poles at which you have found out the residue, if they are going to be complex or imaginary. Then it's going to be this formula, plus pi iota into sum of residue for all those poles which are real, or you can call it the purely real. Okay, now you can have a question in your mind that okay, we are finding the poles, or we are considering the poles which are lying in the upper half of the complex plane or the purely real axis. So how much range we have to consider for the upper half of the complex plane? No such range is there. Neither just 100 or 200 or 5000. No, anything, whatever is in that region, that's what you have to consider. Okay, and the formula to find the residue remains same. Like depending on what order pole you are getting, you will be using that residue formula and you can get the answer. I hope each and everything is clear, but in case if there is any doubt, you can surely let me know and we can talk about it. So this was your type 2 question. Now your type 3 question is, when you will have integration 0 to 2 pi d theta upon a plus b cos theta given to you, or at place of cos theta you can have sin theta too. So cos theta is what? 1 upon 2 z plus 1 upon z. Okay, in this case what will happen? It's going to be, this is what you have to replace for cos theta. If in the denominator anywhere you will have sin theta, you will replace 1 upon 2 iota z minus 1 upon z. Okay, so next thing, d theta you will replace with dz upon iota z. The integration limits which are 0 to 2 pi, you have to replace them with integration over the unit circle C. Unit circle means whose center is at origin and the radius 1 unit. So z is equal to 0 will be there. This is how you will be able to consider or convert your question into a basic kind of question. The only difference is if there is cos theta or sin theta in the denominator, what values you have to put, all that I have shown you here, and that's how you will be able to get your answer done. So let me know if in case there is anybody having any doubt, we can talk about it. But if everything is clear, that's great, great, great. Let's go ahead. Let's talk about the next point now. So after you put all these values, your question becomes a normal question, means the function of z kind of question, which we have already discussed, and that will be easy for you to work on because we talked about all those steps you have to follow to get the answer for any such type of question. Okay guys, let's go ahead. Now when we are gonna talk about the next thing, that's about the open contour. So basically, if you will have any question given to you based on the open contour, what does it mean? it means they will say, okay, this is the contour, for example, but only this part you have to consider. You don't need to include the excess. That's not making it closed. Or this you had only, and you don't have to include the excess. So this is how you can consider that, okay, different open contours we can have. But we know that Cauchy's residue theorem is only applicable for closed contour. So what we will do, if we have just this much given to us, we will include this too, and we will say, okay, it's going to be the closed contour this way. Done. And now we will apply, let's say this is the let me just check the direction. Yeah, let's say this is the direction of the contour. So what I will do, I will initially write integration C plus integration from this A point to B point, because firstly I'll follow the actual path given, and then I'll consider this, and then whatever will be the Cauchy's residue theorem based equation, we will have 2 pi iota into sum of residue and all. We'll be just writing it here. I want to get this, which is integration over the open contour C. I'll just shift it on the other side, and that's how we will be able to get it. Tell me if there is anything not clear to you or any doubt you are going to have, we can talk about it. But open contour, we basically consider it to be closed, and then we just split it in 2 parts. One the open contour part and another one by taking the limits. And this is how we can simply get the answer. Tell me if in case there is any doubt you will have, we can talk about it. And if everything is clear, that's great, great, great. Once you got this much, what next? The next thing is that there are few tricks or few expressions we are going to have. We will be talking about that too. And after that, we'll go ahead for more discussion, okay? So, if I'm going to talk about the tricks, there are 2 different forms we will be having. So what are these forms? Let's consider that part as well. And you can directly use them to get the answer for any such type of question if you will have the similar form given to you, right? So actually, if you will have integration 0 to pi, okay, dz upon, that's going to be 1 plus z to the power 4. I'm just going to change the form here, what it must be, pi by n cosec pi by, okay, minus infinity to plus infinity. So for that, we will be having this form. And how you can consider it, it's going to be integration 0 to infinity dz upon 1 plus z to the power n. So here n must be greater than 1, okay, and you will be able to consider it this way. Just give me a second, guys. I'm gonna write further. Okay, I'm gonna write this expression. Just give me a second, just give me a second. Okay, now if we are going to talk about the next point. So it is going to be this way, integration 0 to infinity dz upon 1 plus z to the power n, where n is greater than 1. So in that case, what will happen? It's going to be pi by n cosec pi by n. Clear? And that's how you can easily find it. If in case you are going to have any doubt, you can surely let me know. We can consider that part. Excuse me. So like, you just have to put the values and you are getting the answer. That's it. Next is integration 0 to 2 pi d theta upon a plus b cos theta. So what it will give you? 2 pi upon square root a square minus b square, right? In this case, what will happen? The a must be greater than b and both should be greater than 0. Clear? So this is how you will consider it, and you can directly get the answer. So you have the information about so many things now related to the contour integration part, from where you can expect the questions to be there in your exam. Now we are ready to work on the questions. I'll be just taking some of the questions now, and that's how we will be able to go ahead for more discussion. Let me just write the first one. Just give me a second. I'll be writing the first question right now. and different type of questions based on what we have discussed till now. Everything we will be trying to consider right now in the session. So I am just going to write the first one. Okay, let's take this one now. You have to find the value of the integral, and the integration given here is integration over the closed contour C dz upon sine square z. Just give me a second. The options are infinity, just give me a second. Options are infinity, 2 pi iota, the next one is 0, and the next one is pi iota. Try it now and let me know as you will get it done. And even I'm going to check out your comments, guys. So if in case you will be having any doubt anywhere, you can surely let me know about it. And if everything is clear, that's great. Try. Let me know if you are gonna get the answer. If you will not get it, I will be helping you to get it then. Okay, let's talk about it. If we are going to talk about sine z, that's going to be z minus z cube upon factorial 3 plus z to the power 5 upon factorial 5 and so on to, right? So if you will take the square of it, in that case, you just have to find the coefficient of C. What is the pole first of all? That is the z is equal to 0. Is it lying within the contour? So that is mod z is equal to 1 upon 2. Yes, that is lying within the contour because it's going to have its center at the origin, that is 0, and the radius 1 upon 2 units. So yes, z is equal to 0 will be within the given contour, which means that we will simply have to consider the coefficient of 1 upon z, which is going to be 0, and we can't have any coefficient of 1 upon z because overall term square is there, even if you will put the sin z series expression there. Okay, so what will happen next in that case? We are going to consider the coefficient of 1 upon z, done. And that's not present, it is 0, so 2 pi iota into sum of residue, which is 0, which is going to be 0 itself, because you know that that's going to be residue, which is coefficient of 1 upon z. Okay, and that's how you are going to get your answer. Please let me know if in case you are going to have any doubt anywhere, we can talk about it, and if everything is clear, that's great. I'll be giving you the next one. So there are so many different type of questions. Oh, okay. I need to tell you one more too. So integration minus infinity to plus infinity, whenever you will have, let's say sine x or cos x or sine z, cos z, whatever you will have there. Okay. So what you will do, you will be writing the imaginary part of e to the power iota z, z square plus 1, minus infinity to plus infinity dz, right? So in that case, what will happen? Z is equal to plus minus iota. Clear? So what you have to do, you will be considering the e to the power iota z there, and that's how you will proceed further to solve it, because it will be giving you the answer quickly and easily, and will make the things quite simple and easy for you, right? If I'm going to talk about the next part here, what is that? That's going to be that even if you will have the exponential in any function and you are having the let's say simple pole, which is order 1 pole present there, so your formula which was having the numerator as it is in first order derivative of denominator, that will be giving you the answer quickly and easily. Okay, so even sometimes it works in a better way for exponential present in the expression. Let me know if in case there is anybody having any doubt, we can talk about it. But if everything is clear, that's great. So let me know if in case there is something not clear to you, we can talk about it. But if you're getting it, I'll be giving you the next question now, which you have to consider. Okay, so let's go ahead. Let me just give you the next one. Minus 2 pi done. Consider it now and let me know if you can get the right answer, but if no, I'll be helping you in that case. I'll be starting the discussion about it just in some time, waiting for your reply, and then in just some time I will be talking about it too. That what is steps you can take, how you will be proceeding further, what will be the easy calculation steps for you. All that I will let you know then. If anybody is there like who is gonna get the answer, let me know. Otherwise, in just some time I'll be starting the discussion too. So actually, it's going to be, if we are talking about integration minus infinity to plus infinity, So sine is what? It's the imaginary part, because you know e to the power iota theta is equal to cos theta plus iota sine theta, right? So in that case, sine theta is what? It's the imaginary part. Minus infinity to plus infinity to the power iota 2x upon x cube dx, right? Now what will happen next? It's going to be, you just have to write the exponential series expansion, which is a 1 plus iota 2x plus iota 2x square upon factorial 2 and so on 2. I'm not going to write rest of the terms. Why? Because I just want to have the coefficient of 1 upon t. And what is t there? T is the x minus pole. Pole will be 0 because the denominator is just having x present there. If I will be equating it with 0, I'll be getting x is equal to 0 as a pole. So then we consider x minus pole is equal to t. So coefficient of 1 upon t is the residue as per the last method I have explained, which is applicable for the order 1 pole as well as order n pole both. So here we are going to apply that one. So if you will multiply 1 upon x cube within this, then in that case what will happen? You will be getting the coefficient of 1 upon x from this term, and that will be 1, like 2 only, negative 2, right? So negative 2 you got as the residue. Now since your value of the pole was what? It was purely real, because you were getting x is equal to 0 there. So when it was purely real, I have told you, for minus infinity to plus infinity case, you just have to take pi iota into sum of residue, which is minus 2. And now if in this case I'll talk about, I just have to take the imaginary part, which is minus 2 pi. Hence option A is the correct one. Okay, let me know if in case there is anything not clear to you or anywhere there is any doubt you will have. We will be trying to consider it. And if everything is clear, that's great. We'll go for the next one. Try this now and let me know as you will get it done. And if in case there will be any doubt, I'll be talking about it too. Waiting for your reply. Otherwise, just in some time, I'm gonna explain this too, like how you will be taking the steps. While we have talked about everything related to this part, so you all know it, you just have to apply the formula and get the answer. So you can see the given function is 1 upon 1 plus x to the power 4, which is a pure, like, which is a even function. Why? Because even if I will be replacing x with minus x here, I'll be getting the same value again, which is 1 upon 1 plus x to the power 4. So f minus x is equal to fx, right? If we will talk about this is the even function, so can I consider it to be integration 0 to infinity dx upon 1 plus x to the power 4, which is going to be 2 into pi by 4 cosec pi by 4. Okay, this is what we are going to have. Pi by sine pi by 4 is 1 upon root 2, so cosec pi by 4 will be root 2. So 2 to the 4, it's going to give you pi upon root 2. Hence your right answer is option A, and this is how you are just going to get it. But tell me if in case there is anything not clear to you, we can talk about it. And if everything is clear, that's great. We will go for the next question then. Let me know, guys, if there was any doubt. Otherwise, I'm going to give you the next question. There are even so many different type of questions we are having. The next one is quite interesting. Let's see how many of you will be getting the right answer for the next question. But if you will make a mistake, it's something you have to be extra careful about. Shown in the figure is try it now. This is what you have to consider and try to get the answer. Let me know what will be the right answer according to you. If in case there will be any doubt you will have, we will surely be talking about it. But I'm gonna wait for your reply for some time. And if something is not gonna get clear to you, let me know. Otherwise, we will be talking about it just in some time, giving you a chance to work on it. But if you have any confusion, any doubt anywhere, you can tell me. We will be considering that part too. Step number one, let's find the pole. So for that, I'm going to equate the denominator with 0. When I will be doing that, I'll get z is equal to plus minus 1. So which means both the poles are lying within the contour. It's correct. Okay. Once you have got it, what next you have to consider? That's going to be what is the order of the poles you got? Its order is like 1 for both of them because overall power of the term is 1. Other than that, if we will consider the next thing, we have to consider numerator as it is in the first order derivative of denominator. So it's going to be z e to the power iota pi z upon 2. Done. And z is equal to plus 1 and minus 1, two values you had. Let's put them. Done. This is what you will get after simplification. Once you got it, you also have to observe this part that okay, the direction of contour is anti-clockwise here, but then it will be clockwise for this part if you will take the arrow ahead. So in that case, what will happen? It's going to be the 2 pi iota into sum of residue for this side, and minus 2 pi iota into sum of residue for this side, because clockwise minus 2 pi iota you have to take, and for the anti-clockwise it's 2 pi iota. So multiply it with 2 pi iota plus minus 2 pi iota of this. So it will be giving you 2 cancelled out, 2 cancelled out, iota square, which is minus 1, and then minus minus plus. So minus pi, which is minus 2 pi. Hence your answer is minus 2 pi. Let me know if in case you are having any doubt. And if it is clear, we'll go for the next one now. I'll be giving you the next one now. Let's take one question from open contour part. The integral I is equal to options are it's option C, that is e to the power 2 iota sine hyperbolic 1, and option D is e plus e inverse. And the figure which has been given is something like this: minus 1 comma 0, try it now and let me know as you will get it done. Let me know whatever will be the right answer according to you. So you will write integration over the closed contour C, okay? As I've told you, even in case of open contour, we start working on the closed first of all, then we split it into two parts, one over C and then another one from 1 to -1 in the direction, like how the other part direction is given. Other than that, you just have to go ahead for the final expression, like for the integration over C. That's how you will be able to get it. Tell me if in case there is anybody having any doubt, we can talk about that part. But if everything is clear, then that's great. If you're proceeding this way, let me know what do you think will be the right answer. Waiting for your reply, otherwise I'm going to talk about it just in some time. Okay, let's go ahead. So basically, guys, if we are going to talk about this integration over C, we have to consider this one. I can initially write integration over the closed contour. Okay, see, I'm considering it to be closed contour. Reason I can't use the Cauchy's residue theorem for the open contour case. So it's going to be integration over C plus integration from 1 to -1. That's going to be e to the power z dz. Let's go ahead. If you will see, there is no pole existing in this case because there will be no such finite value of z at which the function will be infinity or not defined. Hence, no pole, no residue. So 2 pi iota into sum of residue will give you 0 as well. So integration over c e to the power z dz will be -1 to +1. Reason because I'll get a negative sign. I'm just going to shuffle the limits. And this is how I'm going to get this part. Once you have got it, what next? Just simplify the integration and apply the limits. That's it, that's it, that's it, that's it. This is what you will get. E to the power 1 minus e to the power -1, right? What next? The next thing is that you will find that e to the power 1 minus e to the power -1 is not there in the answer. So what we have to do, divide it by 2 and multiply it with 2. This will be sine hyperbolic 1. So 2 sine hyperbolic 1 you are getting. Where it is? It's in option B. Hence your option B is the correct one. You can see how easily you can work on any such type of question. If in case you're gonna have any question, query or doubt regarding whatever we have talked about in the session, you can surely let me know about it and we can try to consider those points then. And if everything is clear, then that's great. So guys, as I've told you about the latest offer which is going on Unacademy in the starting of the session. So if you don't want to miss it, or even if any of your friends want to take the subscription and start the preparation under the guidance of top educators, then in that case you can take the subscription and use and apply the code that's Anjali A Live as mentioned here on the screen, and you will be able to get the discount in the total subscription amount. This is a limited period offer as you can see here on the screen. So it is just valid for a few days, and then it will end. So basically, if you don't want to miss, or any of your friends want to take the subscription, you can share this information with them too. Let them know about the code as well, that is Anjali A Live as it has been mentioned here on the screen, and get the discount in the total subscription amount. Thank you so much everyone for joining this session and for attending it till the end. What are the benefits you will get if you will take the iconic subscription? I'm going to show you right now on the screen. At the same time, in plus subscription, in light subscription, in the CSIR UGC net subscription, like different subscriptions plus iconic and light, everything has been shown here. So I hope each and everything will be now clear to every one of you. Let's keep it this much right now. Thank you so much everyone for joining this session and for attending it till the end. Thank you.